All right, welcome back to C Sharp. So I'm gonna say for the record that this is take 70 of this video. And this time, if I screw something up, I'm just gonna probably continue to go with it. And yeah. So what we're gonna do is we're gonna talk about Yahtzee. So the sort of next sort of code along that we want to do is a much more involved scenario than the things that we've done in the past, either for the small videos for specific kind of topics, or for the longer videos for actual applications that we've developed, so the weighted calculator and that kind of thing. So what I want to do first is I want to talk about the rules of Yahtzee, what it actually does. Then I want to take you through my code as a sort of runnable experience. I want to actually show you the app. And then I want to go through the code itself and kind of show you how I structured things and how this represents a much more complex object-oriented scenario than we've seen in the class so far. But it also is very classically object-oriented. So we're going to have classes that have both state and behavior. And in general, the architecture is very, very kind of vanilla. There's not a lot of moving pieces to it. Although there are many, many classes, the relationships between those classes are fairly straightforward. And so immediately after this, we're going to start talking about architecture in a more broad view throughout the course, and we're going to start our sort of trudge toward REST APIs and headless services. And so this is going to be kind of the capstone on the syntax or the sort of rudimentary background information for the course. And so from this, we're going to use sort of classical object-oriented programming as a springboard to go to the next level of kind of complexity. So the main idea of Yahtzee is that you have some number of people, usually 2 to 4, and you have a number of dice. So you have 5 dice, and you have a cup, and use the cup to roll the dice. And you can roll the dice up to 3 times, and between those 3 rolls, you can hold a dice to maintain its value. So if you roll a whole bunch of 6s, you want to keep your 6s, you can do that. And you can either forfeit your remaining rolls, or you can put the dice you want to re-roll back into your cup. So 3 is kind of a maximum, and then the hold functionality allows you to keep dice rolls that you like. So at the end of the day, what you're trying to do is after 13 turns, you're trying to get to the biggest score using the rules inside of this scorecard. And so this scorecard gives us the opportunity to talk much more about more complicated parent-child relationships in terms of modeling a scenario with C#. So I want to take a look at some of these scores specifically. So at the top, in the upper section, all of these things have essentially the same rules. So you're going to count up, and you're going to add only a certain type of dice. So 1s, 2s, 3s, 4s, or 5s, or 6s. And there is an additional piece here that gives you a bonus in the event that you've actually scored higher than a certain amount. So this thing up here is an upper score. These things down here are lower scores, and so lower scores typically have kind of these one-off rules. So you have a 3 of a kind or a 4 of a kind, full house, low straight, high straight. So low straight is a series of 4 numbers, high straight is a series of 5 numbers, a Yahtzee, and then you have kind of all of the grand totals at the bottom. So in general, what we have here in the scorecard is a longer chain of parent-child relationships. And so at the beginning, we have just sort of the concept of a row or a line item in these cards. And then from that, we have an upper section that allows us to implement a very specific type of rule that is related to how many of a certain number you have in terms of dice. And a lower section that allows us much more flexibility in terms of what rules we can use to implement what the score is. And so what we're going to find is we're able to model all of these things off of a common base class. And then we have an upper section that is a derived class, and then each of these things are going to become their own derived class. we're also going to use an interface to require a score method that will give us the actual score of what the line item is. So enough about Yahtzee the game. Let's go ahead and see it. So in my program, I have the first prompt is how many players would you like to use? So I want to use 2 of them. I want to use Bob and I want to use Sue. So here Bob has rolled. His rolls are 4, 5, 5, 6, and 4. And let's say that he is trying to go for a full house. So in that case, he would want to hold 1, 2, 3, and 5. So that would re-roll this 6, and we would hope that that 6 would give us either a 4 or a 5, which would give us a full house. So if we hold those, my second roll is a 1, which is not great. And I can roll again by holding nothing, and lo and behold, I get a 4, and so that gives me 3 4s and 2 5s, which is a full house, and my algorithm has selected the full house line item for Bob, and now Bob has 25 points. Fantastic. So now Sue has a 3, a 6, a 2, a 4, and a 6. So now I can say what I would really like to see happen is maybe I could keep the 3, I could keep the 4 and the 6, and then hope that I get something in here that will allow me to have a straight. So if I keep those values, I have a 3, 4, and a 6. I don't get anything that's useful because really what I want is a 5, because that would give me a small straight. I could keep this 2, which would give me the ability for a long straight if I roll a 5 on the next round, which is not as likely as using 2 dice to get a 5. So I'll roll both of them, and I failed. So I did not get a 5 with either of the 2. And so the best that Sue could do is chance, which allows you to add up all of the dice face values. And so here, if you add all of these together, I get 10 plus 4 plus 4 is 18. So 18 got chosen to be her value. So now I'm on round 2. And so here, Bob already has a 3 of a kind, 4 3s, and so I'll go ahead and hold those. So I want to hold the 3rd, the 4th, and the 5th dice. That didn't help me, it didn't give me any 3s, and then that didn't give me any 3s either. So now I get to keep my 3 of a kind, which gives me 11 more points. His total points get bumped up to 36, and then we continue to Sue's turn. So here, Sue is going to attempt the full house, so 1, 2, 3, and 4. That is going to give me a 1, which will give me a full house, which I will keep. Oh, I messed up. I should have kept that. Anyway, I should have held that, and she would have got a higher score, but I didn't, so she gets 5s. And so she has 1 5, which is more than 2 points or 4 points. And this at least shows you that the top part also works. So we're gonna do this one more time because I have mine set to 3 rounds. You can see in the background here. And so for this round, I'm going to, Bob is gonna go all in on 1s. So I'm gonna have 1, the 3rd one, and the 5th one. And I'm gonna get a 5 and a 2, which is not great. I want all 1s, so I don't really get that. And so I end up with a 1, 1, 5, and a 6. And the best thing for me is a chance at 14 points. So Sue now has 3 6s, which is pretty great. So she will hold 3, 4, and 5, and then roll again. And at least she now has a 3 of a kind for 6s, which gives her all of the points across the board. And so this is going to add up to be 24 points. So at the end of the day, Sue has 47 points. And Bob has 50 points, which means that Bob is the winner, and everybody, I guess everybody, where everybody is Bob, is happy, and then we can exit. So how does this thing actually work? So first off, we have a main method, and what we've tried to do is we've tried to kind of compartmentalize all of this logic such that we have as little information in the program class as possible. So here what we're doing is we are adding up 5 dice. We're adding 5 dice to our list of all dice. And we are setting the total number of rounds to 3 instead of 13 because we wouldn't want to play 13 rounds necessarily just to test things. Then what we're going to do is we're going to ask the user how many players are going to be playing, and then we're going to inquire about those players' names. So this stuff is exactly the same that you've been doing for a very long time in the course about setting the properties of a model before you add it to a list or something like that. This is functionally the same as the shopping cart app. So inside of this, this 3 lines of code actually is the only kind of logic that is held inside of program other than trying to figure out who the winner is. So what we're doing is we are setting the list of players up here, and then we're ordering or iterating through the list of players for the specified number of rounds, and I'm making this a win-based list because I don't want to display round 0, round 1, I want to show round 1 through 3. And so if we look on players, that is where the actual kind of meat of the code is. And so in here, we have this play method, and the play method actually walks through and does all of the actions for the user. So it implements if the user should hold dice or if they should not hold the dice, and it also manages the lists. So it figures out what dice are held and which dice are not held, and sort of walks through all of that kind of stuff. It also calls this score method, and the score method here goes through the scorecard, which is a property of the player, and marks the correct line item on the scorecard based on the potential score. So essentially what's happening is it's computing all of the potential scores for all of the potential line items, and it's going to pick the line item with the highest score to be that person's choice. That's what's happening here. And so what we've done is we've taken the majority of the actual playing implementation and we've pushed that to the player instead of leaving it in the program code, which is significantly different from what we did with the shopping cart. So now what we're going to do, and you're free to kind of go through this. I'll post the code on Canvas. I'm not going to belabor a lot of these points because they're going to be very, very trivial to you. It's for loops and if statements. It's going to make a lot of sense. What I want to do is I want to spend the most of the time talking about the scorecard. So if I go to the implementation of the scorecard, if you haven't noticed this yet, you can right-click on a type name and you can go to implementation. And that will take you to the code wherever it might be, buried in 5,000 lines over here. And we're going to kind of start at the top and then work our way to the bottom. What these are doing is these are properties that again only have a getter. And the point is that a person should not be able to come in and usurp the individual line items on a card. They should have to rely on the card to compute and then give them the value of the top and the bottom score and the grand total and the bonuses. So these are functionally equivalent to the total, the subtotal, the taxes, all of those properties that we saw on the shopping cart app before. I would walk through these and just make sure that you kind of convince yourself that implementation is basically the same. But what we're doing here is we're showing that you can nest these things. So I can call top score and top bonus from grand total. I can call top score from top bonus, and remember back over here, if I have 63 or more, I have a 35 point bonus. And so this is how we're implementing that. So in my constructor for the scorecard, what I'm actually doing is I am modifying or adding to line items. And so line items is a list of score line base. And score line base is going to be the parent class for all of the derived classes that actually implement the way to produce the score. And so we're going to spend maybe the last half of the video kind of talking through that. So the thing to note is that I have many different types of line items that I'm adding to my list of line items. The first 1, 2, 3, 4, 5, 6 are all upper score line items. And there I provided a name and I provided a number. And so this number is going to be the number of the dice face that corresponds to this line item. So if you go back over here, I have 1 for aces, 2 for twos, 3 for threes, 4 for fours, and so on. Then I'm going to add a 3 of a kind, a 4 of a kind, a full house, a small straight, a large straight, a chance, and Yahtzee. And this is the entire sort of state of the scorecard class. Everything aside from that is going to be behavior on this or behavior on a property that is one of these line items. So the mark method is what is being called when the player goes through and tries to figure out what line item is going to give them the highest score. So what is going through and happening here is we're going to iterate over each of the line items and we're going to pull out the line item object. We're going to compute the score based on the dice that the person threw. And then if that potential score is going to be bigger than the current maximum score, we're going to mark that as the chosen I, or the chosen line item. And then ultimately what we're going to do is at the end, if I've chosen something that is greater than 0, I'm going to mark the line item and I'm going to mark the score, which is then going to kind of deep persist the score line item, and it's going to eliminate all of the potential line items that it didn't choose. So this part up here allows you to implement the fact that if a person scores a Yahtzee, which is an 8% chance, I think is the math behind that. If they score a second one, Yahtzee is the only thing that you can actually mark twice. So if you get 2 Yahtzees instead of having to pick another item, you actually get a 100-point Yahtzee and you basically insta-win the game. And this implements that. So if the line item is marked, I want to continue past that line item because I don't want a person to be able to choose full house 4 times or 2 times. If it's a Yahtzee, though, I do want them to be able to choose that as many times as they want. And if they choose that more than 1 time, then they get special bonuses for that choice. So let's go to score line item base or score line base, and that will, let's talk about this first. So the toString method on the scorecard, this is what formats the scorecard. So when we were going through our example, I could show the top section and then the bottom section. Right now, this is all predicated on the order in which the line items were added to the list. You could just as easily add a property on each line item to give it an order value and then order them down here if you'd like in the for each loop. You can do really anything you want. This toString method is, again, functionally equivalent to the toString method that we provided for the shopping cart. So basically we're iterating through the line items and we're doing special things if the line item is an upper score line item or a bottom score line item. And so we'll talk about what this is in just a minute. So scoreline base. So scoreline base is an abstract class, which means that it itself does not provide any method implementations. So I have a score method here that is marked abstract, which means that all of its derived children or the derived classes from this class are going to have to provide their own method of scoring. So you'll notice here that I've also implemented an interface. So I've created my own interface called iScoreline. And what this does is it enforces the fact that the base class must have a score method. And so because I am implementing this, this interface, if I try to get away without having this, I would get a big nasty error that says, hey, you have to have at least an implementation member for the score method. And if my implementation member is abstract, I can essentially delegate the implementation to derived classes. And so that's what's happening right here. So this is intended to show the primary use case in C# for interfaces is enforcing that code that is going to consume pieces of code that you have written are doing so correctly and in a consistent way. So we went over the kind of age-old adage that these are contracts, and that's exactly what they are. And the contract enforces the fact that a method of this signature has to be present on the base class. So if we go to the immediate children of scoreline base, we're going to find that we have upper scoreline, which implements scoreline base, and we have bottom scoreline, which implements scoreline base. And we're going to start with upper scoreline. So upper scoreline has two public properties that are kind of special to it. It has a target. This is actually going to tell us what dice roll corresponds to this line item. So if you're trying to get 3s, you would only consider dice that have a base value of 3, for example. Our constructor is very kind of rudimentary. It allows us to set the target and the name for each of these properties. And if you go back to scorecard, that's what you see here. So we're setting the target and we're setting the name of those items. So the score on each of these things is going to be such that you want to count up the number of target values in your dice list, and you want to return the count for that target. And so this is actually an alternative strategy for scoring. And if you see over here, this is, oh, never mind. This is for aces over the top part. So if you're looking to score 1s, for example, I'm going to count up how many 1s are in the dice list, and then I'm going to multiply the number by the target. So the target is 1s, in this case is 2s or whatever. If I find 4 2s, I'm going to return 4 times 2, which is 8, as the score. The toString override for the line item is going to be of this general format. It's going to give me if the thing is marked or not, the name, and then the value that I have. This comma, -20, and 4, these are padding. So this will be left padded with spaces by 20 characters, up to 20 characters. Those will be right padded by 4. Here, if I am marked, I will display the marked symbol. If I am not marked, I will display an empty set of brackets. One thing that you can do to kind of test your knowledge of how inheritance or this implementation actually works is you can take the code from Canvas and you can attempt to rearrange the code such that this toString method is actually on the scoreline base instead of the upper scoreline and the bottom scoreline, because here each of these specialized versions is going to have a duplicate essentially of this code, which is a code clone technically, and it's not very nice, but this is kind of a naive way of doing it. So if you're interested in kind of an additional assignment to kind of make sure that you understand what's going on, you should try to take these toString methods off of upper scoreline item and chance and full house and whatever, and try to get them down to scoreline base so that each of the score lines can be called in the scorecard directly from the parent class and not the derived class. So that gives us all of the upper stuff. If you look at the bottom, what's essentially happening is we are doing, it's not bad, it's certainly not as good as providing an implementation, but what we're doing here is we're providing an intermediary derived class. So this is derived from scoreline base, But if you look at chance, for example, chance is derived from that derived class. And so this is our first example of I have a parent, and then I have a child, and then that child also has another child. So if I look at bottom score line, what is happening here is I'm getting an order that we were talking about before, so I can order the line items in the bottom of the scorecard. And then I am enforcing the need for a score implementation. This is required because score line base is abstract, and that score implementation is abstract. And if I don't have this, for example, the compiler will bark at me and it will say, oh, well, you have to implement this abstract method, and that abstract method has to be there because of the interface that we put in at the very beginning. And so you can kind of see the cascading effect that inheritance and interfaces have on the situation. So we don't actually have any concept of a bottom score line, and if you go over here, it's unclear what you would actually provide as a scoring mechanism because they're all so different. So what we're going to do is if a person tries to just add a bottom score line and they try to call score, we're going to blow up. And this is kind of by design. This is part of fail fast ideology. And if you try to implement something like return 0, that might be very confusing to a person that's using the class that isn't necessarily the person who wrote the class. But if you throw an exception, it will be very obvious to them that they are not supposed to be using bottom score line by itself. It is really an intermediary. So this one tends to be, or turns out to be quite a bit easier than the upper score line item. But if we go to something like chance, we see, again, the code clone for toString, but we also see that each of these things is going to have to implement its own score algorithm, which is just kind of the way that Yahtzee works out. So here what we're doing is we're using a link expression. There's going to be a separate video and page about exactly what all of this means, but in a quick kind of pragmatic sense, what we're doing here is we're taking a bunch of dice objects. We are selecting the value from each of those, and then we're summing that value up. So on this side of the select, I have a list of actual reference types of type dice. On the right-hand side of it, at this dot, I have a list of integers, and then this dot sum allows me to get the sum of those integers. And if you look at the algorithm, it should be the total of all dice, and that's exactly what this gives you. It gives you the total of all the values of all the dice. So you can go through each of these and kind of convince yourself that these implementations match these rules. But the main thing that I want to show you also is static classes, which we kind of talked about in the pages, but we didn't necessarily do a lot of implementation around. So if you look at Yahtzee helper, what Yahtzee helper is a static class with a whole bunch of static methods. And it turns out that static classes have to have static methods. It's impossible to have a non-static or an instance method on a static class, which makes sense because static classes can't have instances. They're kind of restricted from doing that. So what this is doing is it is allowing us to implement what are called helper functions outside of individual implementations or instances. So you can look through here and it will become obvious that these are things that will be used across multiple different classes. So for example, getting the dice string, what that does is it takes in a list of dice and it returns a flattened comma separated string of the values of those dice. So clearly this is going to be used in the program, but it's also going to be used in scorecard. It's going to be used in all of the line items that need access to the dice, string itself, so on and so forth. Get maximum groups. This is going to get me the number with the most dice associated with it. So this is going to allow us to do things like if I have 4 2s and somehow a person wants to play Yahtzee with 9 dice instead of 5 dice, we would obviously want to choose 4 4s over 4 2s. So this is a way of providing kind of forward-looking functionality without necessarily needing it right now. So we would use get max groups for things like full house, or like 3 of a kind or 4 of a kind. And max groups would allow us to distinguish a group of 3 versus a group of 4, and obviously choose the group of 4 because it's going to give us the larger point total. Well, in some cases, it'll choose whichever one is the biggest. We have get groups, which will actually return to you the list of dice that are grouped. This is also used for full house, because full house you have to have 2 groups of dice, and this can be used to understand when you're in that scenario where you can actually mark full house. And we also have get run size, which gives us if we have a run of size 4 or 5, which tells us if we are able to mark either the short or the long straight. One more time, I'm going to kind of try to put it all together. So we have the program class, which implements all of the actual kind of bare bones main features, orchestrates everything, iterates through, and gets down to calling the play function or method on each player in the list. Once that player's play method is called, we jump into here, and then we do the sort of roll dice, hold dice pattern over and over and over again for however many times we specify they can have rolls. And so in this implementation, we have hard-coded that to 3, but we could also have many variations of Yahtzee where a person could play with 17 dice and they could have 48 rolls. And so this also provides us kind of forward-looking functionality. This is a thing that we're going to talk about throughout the class. It's another form of scalability. It's called feature scalability. And here, if we wanted to suddenly have any arbitrary number of rolls, we would be able to support that natively. We wouldn't have to actually change any code. The one note here is that many of you have had internships, and you will have heard the name magic numbers and magic strings. This is technically a magic number because I'm just passing in a 3, but IntelliSense will quickly tell you that that 3 is the number of rolls. Traditionally, you would want something up here that says number of rolls equals blah, and then you would use that identifier instead of a 3 here. But for the purposes of slamming through this code, I just put a 3. So at the bottom of the player, what we're going to do is we're going to call the score, and then we're going to call the pass turn. So pass turn, what it does is it resets the dice list, and it's going to pass the turn over to the next player. What score is going to do is mark the scorecard using the current set of dice. So if you look back over here, we're actually passing in the held dice. Because at the end, we're actually going to take all of the dice and put them in the hold list, and then use that use that to calculate what the score is actually going to be. So if we go to implementation on this thing, and we go to the scorecard. So if we go to the implementation on the scorecard, you will see that again, we're back here where we're iterating over line items, and we are figuring out what the maximum possible score given this specific set of held dice is, and then we will pick that, and then ultimately we will go back and we will display what the selection was. So we go through these print cycles where we print what the held dice are, what the final result of the rolls are, and then we print the scorecard. And now we've seen that we have upper score line items that allow us to do the top part, and we have bottom score line items that allow us to distinguish all of the derived classes that are derived from the bottom instead of the top. And so this intermediary type, the place that we use it, is figuring out where to put the sort of sections of the scorecard in the print statement. And here we're doing another link statement, which we'll talk about shortly, to get only the line items that are set, and also get them in the order of their specified order. And so this is going to allow us to maintain this order even though we might be shuffling things around, trying to figure out which is the highest point total. So this is, again, just kind of an example of what link looks like. I want you to see the syntax before we go through what everything means, just so that you are kind of aware that it exists, and then maybe that will motivate you to understand what it means. So that's the long and short of Yahtzee. I'm going to post the code. There's quite a bit to it that you might want to sort of dig through and work through. If you have questions, comments, concerns about it, please let me know. I'm happy to walk back through it on a sort of private chat or whatever you want to do. The second programming assignment is not as complicated as this. It's actually using the first programming assignment and kind of extending it a little bit. And I will be posting that kind of imminently. I just wanted to make sure that I got this out first so you had a little bit more of a complex scenario to look at to do that work. So thank you very much, and I will see you in the next video.